Welcome back to the video series of Python programming. I am your instructor Shweta Yagnik, and today we will continue with our OOPS concept in Python. So the topics that we are going to cover today are first abstraction, then we are going to see types of variables and types of members. So let's begin with our first topic, that is abstraction. As the name suggests, abstraction means hiding the details. If we don't want to expose all the details to the user, then we'll use the concept of abstraction. That means user should be aware about the information that is necessary for him to know. Okay, in last lecture I have explained you abstraction means the user is aware about what function is doing, but he is not aware about how it is to be done. So today we are going to see how to implement abstraction using different variables in Python. So next thing that we are going to see is notion behavior. Okay, so first is public variable, everything whatever declared in Python class, that is public. Then protector variable, if we want to use the protected variable, then we'll be using convention underscore then variable name. Okay, so in order to access those protected variable, we'll be using object dot name. Then comes private variable. If we do not want to show some of the details to user, that particular detail must be declared as a private. Okay, so private variable, the naming for the private variable will be as it is shown over here, underscore variable name. And in order to access the variable name, you cannot access directly object name dot variable name as we used to do with the normal variable. But here the in order to access those variable, will be using object name dot underscore class name, then underscore variable name. So this is how the private variable will be accessed. Now we will see different types of variable in Python. So first type is the instance variable. As the name suggests, these variables are created per instance of the class. That means per object of the class. So the scope of the variable, the scope of instance variable will be the object. Okay, so the constructor is used in order to initialize the instance variable. So wherever new object is created, wherever the new object is created, your constructor will be called and will initialize your instance variable with the specified value. You can use the parameterized constructor also in order to initialize your instance variable. So for example, if x is an instance variable and if we are having three different objects, that means three separate memories will be allocated for the variable x, which is specific for or individual instance. It is available for individual object. Okay, so if you modify in any one object, it will not affect the rest of the objects x. So next type of variable that we are going to see is class variable. As the name suggests, it is not specific to object, but it is common for all the objects. So the scope of this type of variable is to the class. So even if you modify the variable, it will be reflected in all the objects because the memory is common. It is not separate for the individual object as in case of instance variable. Okay, so object needs to be created. Then class variable will be used by class method. Then if we want to modify, we can access it using object as well. Next is a static variable. So it will be used by the static method. Okay, as I have mentioned, the class variable will be used by class method and static variable will be used by static method. But the difference is that in order to access the static variable, we don't need to create the object of the class. Directly we can use it using class name. So shortly we are going to see different methods using which we can use it. So the class method and static method. So first is instance method to access any of the instance variable that we have already used last time. So next is a class method. In order to create a class method, we'll be using a decorator called class method @class method decorator. And in case of instance method, we used to provide the self parameter in order to refer to the current reference, okay, with which you have called that method. But in case of class method, we'll be using CLS as the parameter in order to identify that is the class method. So one thing, we'll be using class method decorator, and second thing is that in a parameter of the method we'll be passing CLS as a parameter. So generally it is called as class name dot method name. This is the way how it is to be accessed. Now next type of method is called a static method. So in case of static method, we need a static method when processing it as a class level, but we do not want to involve any of the class or instances. Suppose we want to find out how many objects are created, okay, so that can be done using the static method. There is no need to pass any of the parameter, okay. In other two cases, while in instance method we used to pass self parameter, in class method we used to pass CLS as a parameter, but in case of static method we are not supposed to pass any of the parameter, okay. There is no need to create any of the object before calling to this static method, and here @static method decorator will be used, okay, in order to create the static method. So now we'll see practically how to use different variables and methods. So now we'll realize how to implement abstraction in Python. So first we'll be having a class called encapsulation, in which we'll be having a constructor. We'll be using over here parameterized constructor. As you know, the first default parameter, that is self, then A, B and C. These are the parameters with which we'll be initializing our instance variables. So here we'll be having self dot public equal to A, self dot underscore protected. This is the variable name, but underscore is supposed to be used if we are declaring a protected variable. So we are initializing it with B. Then self dot underscore private equal to C. So now we are out of the program, and now we want to will create an object, that is object equal to encapsulation here print ob dot public. Then we'll try the similar thing to access our protected. And that's it for now. We'll see this first. Okay, we are supposed to pass the argument. So by default I'm initializing with 1, 2 and 3. We are not supposed to pass any parameter for self because the object is by default will be passed as a parameter. So now 1 and 2. Okay, now similar way, if I want to access the private variable, let us see what happens. This is the name of the variable private. Let us execute it. No, escaped object has no attribute underscore private. Okay, so we'll see that underscore and cap, that is the name of the class, and then following two underscores and our variable name. Let us see this convention, and with this we will be able to see, we'll be able to access the private variable. So this is how we can have different types of variable in order to achieve the abstraction and encapsulation within the class. Now we'll see how to implement and access instance variable. So for that I'm defining a class called my class, and within that I'm having one instance variable, and for that I'm having the constructor within which I'll be initializing that variable. So def init, and self I'm supposed to pass as a parameter, and within that I am initializing x, that is my instance variable, okay, to 10. But in order to access that variable I'm supposed to use the current reference, that is self dot. Okay, so now I am trying to implement a method, that is instance method, because I want to access instance variable. So I am defining def, then modify is the name of the method because I am trying to modify the value of x. So here also I am passing self, and within that I am trying to modify it self dot x plus equal to 1. I am incrementing the current value by 1. So this is how I have created the instance method to access instance variable. Okay, and for instance method it is compulsory to have self as a parameter. So now we'll be creating object. So here I'm having ob1 is equal to my class, and here we are not having parameterized constructor, so we are not passing any value. Similarly, I am creating two objects so that we can clarify that instance variable are having separate memory address assigned specific to individual object. Okay, so there are two objects that I am creating, ob1 and ob2, and I am printing the value of the current I am printing the current value of x, that is my instance variable. So ob, or rather I'll write proper message so that we can understand it properly. Before modification, value of x in ob1. Okay, so I hope you are getting by this message that we are trying to access the value of x within ob1, that is object 1. Okay, so in order to access the instance variable I'll be using ob1 dot x. Similarly, for ob2 I'm writing the same code, but here ob2, and here I'll be using object 2. Now let us execute the code and see. So before modification both objects are initialized with value 10, because when we create ob1 it has called this constructor, okay, and it has initialized it with 10. When I have called this object it has initialized the instance variable with x only. Now what I am trying is I am trying to call ob1 dot modify. That means I am trying to change the current value of x using the instance method. Okay. After this, obviously the value of x is modified within ob1 because I have called the method for ob1 only. So let us execute the code and see. Yes, so it has changed the value of x in ob1 by x. But now what about ob2x? That means the instance variable of object 2, has it been modified or not? Let us check it. So I should be writing over here after, because I'm calling this after I'm writing this after calling this modification method. So this is also after. Okay, now here I should be writing ob2. Now let us execute. Yes, so it has not changed the value in ob2, which is quite obvious because both memory locations are different, so it is not supposed to change the value. Now we'll see how to declare a class variable and how to access it using class method. So here I'll be using this similar class, and within that class I'm having a variable. Okay, this is a class variable. It is not defined within any method. Okay, so it is a class variable. Now in order to access the class variable I'll be requiring a class method. For that I'll be using class method decorator. Okay, then def modify, And within the class method, it is compulsory to pass the parameter called CLS. Okay, it is programmer's convention to use the parameter name as CLS. In instance method, we used to pass self to refer the current object, and in class method we'll be passing CLS. You can use any name, but it is a programmer's convention. So we'll follow this over here, and in order to modify the class variable, we'll be using dot operator CLS dot X, and we'll be incrementing it by 1. So this is how the class variable can be accessed and modified. Now similarly here, which we have done in instance method, we'll be creating two objects, OB1 and OB2. Okay, and then we'll be accessing OB1 dot modify. Or before that, I should be printing what is there inside the class variable. Okay, so let us see this and execute the code and identify. Okay, we are getting over here one error. Okay, the class name, the name of the method is CL modify, so that's why it was giving error. So yes, now both objects are having same value assigned to X. Now we have used OB1 dot modify method, so I am calling that method only for object 1. Okay, now let us see what happens to object 2's X. To see that, so after modification, both the values. So can you see the difference here? Even though we have not called the modify method for OB2, it has changed its value because X is assigned a common memory for all the objects. That means it is common. Even if the one object is modifying value of X, it will be reflected in all the objects because the memory is common. The scope of the class variable is to the class, not to the object. That's why we are seeing this behavior. The another way of accessing the class variable is by using the class name. So we can use print my class dot X. Let us see this. So yes, we are able to access the class variable using the class name. Okay, now we'll see how to use the static variable and static method. So for that, we'll be creating a similar thing. A variable having X, then we'll be having a method which is, we are supposed to use the decorator static method def modify. Here our method will not be having any of the parameter, because in order to access the static variable we are not supposed to create any of the object. It's not compulsory. So in parameter we don't need to pass anything to accept the current reference because we don't have any objects. So here we'll be having, we can write directly without performing any of the increment. We can write this way, print in modify method, and in order to access the static variable we will be using the class name, that is my class dot X. Okay, and we'll check how it is performing. So out of the class print, I'm trying to access the modify method, which is a static method. So my class, that is the class name dot modify. I'm not creating any object here in order to access the method. Okay, I need to pass. Supposed to give over here. So it has returned none, that's why it is returning me none. So here in modify method end 10. Okay, so I'm not supposed to enclose it within print because modify method is already having a print statement. So yes, this is how it should be accessed. But now if we want to have a counter of how many objects are created, so we'll see how to do that. So here I'm having a particular constructor in it, and self. So here I'll be incrementing every time when new object is created. That means at the time of creation of object, my constructor will be called, and in constructor I am incrementing my static variable. That is what my plan is. So here my class dot x plus equal to 1. Okay, and after class I am creating 3 objects. ob1 is equal to my class. Similarly I'll be having 2 more. One more I'll be having 3. Okay, and after that I'll be printing what is the final value of x. Okay, so let us print it. So yes, it is a 13 because initial value is 10, and at the time of creation of object 1 it has incremented x value by 1, that is 11. Then after I have created one more object, so 11 plus 1, that has become 12, and after that I am again incrementing the value, that is 13. So after creation of all the objects, when I print the final value of x, it is giving 13 because it is common for all the objects. So I hope you have understood today's content. Keep watching our video, and see you in the next video to explore the further concept of hoops. Till then, keep learning.